This is my geometry course. Today we're going to learn volume. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, we learned how to find two-dimensional space. Well, actually, let's start with one-dimensional space. So let's say you have some sort of a line segment and you want to measure the length. This is one-dimensional space. So you might take an inch units, and you might try to figure out how many times you can fit an inch into that length, and that would be measuring one-dimensional space. That's not exactly an inch, but you get the point. Now, if you try to measure something like a piece of paper, you try to measure two-dimensional space, then you're trying to fit squares inside, and you want to figure out how many squares you can fit inside that two-dimensional space. And those squares are supposed to be the same size, but you get the point. So area is measured in square units. Two-dimensional space is square units. Now, if you have three-dimensional space, let's say that you have a rectangular prism. It looks something like that, and you want to figure out how big this three-dimensional space is, then what you do is you put cubes inside. And you try to measure how many cubes can you fit inside, and that's measuring three-dimensional space. A cube is just a rectangular prism where all the sides have the same length. This side, if this side is x, then this side must be x. The width must be x also. That's a cube. So it's kind of like an ice cube, but not all ice cubes are exactly the same length on each dimension. So the first thing we're going to learn is how to find the volume of a rectangular prism. We learned how to find the surface area of a rectangular prism in previous classes, but now we're going to do volume, and you can see that this formula is pretty easy. So the volume is equal to length times width times height according to that formula. Now, I want you to understand, by the commutative rule of multiplication, it doesn't really matter what the order is for these numbers. Now, obviously, if we set the rectangular prism in like so, then this would be the height. So that would be h. And this would probably be the width. That would be 5. And this would be considered the length. But it doesn't really matter, again, because of the commutative rule of multiplication. You can put these in any order you want. And also, if you take this rectangular prism and you set it up so that this is the top over here and this is the bottom, then the length, width, and height would change depending on the orientation. So again, it just doesn't matter what order you put it in. So we're going to multiply all those together, and it looks like we get 90 cubic centimeters. Now, it's very important that you put cubic centimeters. That means if you have a cube, that doesn't look like a very good cube, obviously, but if you have a cube and this length is 1 centimeter, and this length is 1 centimeter, and this length is 1 centimeter, that's this space inside here is 1 cubic centimeter. And we're counting how many cubic centimeters can fit in there, and it says 90 cubic centimeters. So let's try another one of these. Let's say you have that looks like a tower, from a desktop computer. Let's say you want to measure the volume. Then V is equal to length times width times height. And you don't have to show that formula every time. It doesn't really matter. So this would be considered the height, right? And this would be considered the width. But it doesn't matter. I can put 8 for the width, and or for the height I can put 2. It doesn't make any difference. And put the 8 over here. I can arrange those any way I want. I'm going to get the same answer. So that would be 128. And you can use the calculator to multiply these numbers because they're getting kind of big. That's okay. The important thing is that you know how to use the formula. So the volume is 128 cubic feet. All right, so I want you to try number 3. And when you come back, we'll do it together. All right, we're back. Volume equals length times width times height. And I'm not going to write that formula every time because I think you get the point. It's just not really necessary. And we get 160 cubic millimeters. Be sure to write cubic units with that third power there. That third power means cubic millimeters. So if you got 160 cubic millimeters, good job. Go ahead and try number 4. When you come back, we'll do it together. All right, we're back. volume equals 1 times 3 times 3.2, and if you had to use the calculator, that's okay. 3 times 3.2 is 9.6, so we have 9.6 cubic inches. And again, be sure to write that third power there. If you just write inches, it doesn't make any sense. We're not measuring volume anymore. So that's how to find the volume of a rectangular prism. It's much easier than finding the surface area of a rectangular prism. On to volume of a cylinder. Now this is a cylinder. A cylinder would be like a soda can, or if you've ever bought cookie dough, it usually comes in some sort of cylindrical thing, if you know what I'm talking about. And there's a lot of examples of cylinders. For example, a cylinder inside an engine. It goes up and down in this combustion chamber. The spark gives it combustion. It blows up and it pushes this cylinder down. That's an explosion there, and you got your cylinder here. So there's cylinders. There's just thousands of examples of cylinders in the real world. To find the volume of a cylinder, it's pi r squared times the height. So you find the area of the base, the top, or you can do the bottom, and then you multiply by this height. So let's do the first problem here. I'm going to write that formula down, pi r squared h, and pi is just a constant. R is going to be 6, and the height is 20. So pi 6 squared is 36, and you can get your calculator out. It doesn't, don't worry about that. It's going to be, looks like 720 pi cubic meters, and you can leave your answer in terms of pi. I said here, leave your answer as a multiple of pi. So if you want to find the answer in decimal form, all you have to do is take 720 and multiply it by pi in your calculator, and you can find that way. But again, I gave you specific instructions to leave it as a multiple of pi, so I'm just leaving it as 720 pi cubic meters. Let's try number 6. Now for number 6, it can be kind of confusing because the cylinder is on its side, you see. So it looks like this is the height, but that's not considered the height. This is the diameter of those circles. This is considered the height, so don't be confused by that. It's really important that you understand what's going on here. So volume is equal to pi r squared h. Pi times, now r is not 10. R is 5. I had to take 10 and divide by 2. Do you see why that is? Don't get tricked by that. 5 squared is 25. And final answer is whatever 25 times 18 is. So I can do that on my calculator real quick. 25 times 18 is 450. So 450 pi cubic inches. So why don't you try number 7, and when you come back, we'll do it together. All right, we're back. Let's see here. Volume is equal to pi times r squared times the height. I don't really require you to write the formula every time you do this. I just don't think it's really that necessary. Most of the stuff in this class is going to be really easy, so it's not really that big of a deal. The whole point of this is just to get you used to these formulas, but they're not difficult. So try number 8, and when you come back, we'll do it together. All right, we're back. Volume is equal to pi r squared. Now, r is not 4. R is 2. The diameter is 4, so be careful with that. And the height is 9. And doing that math, you can probably just do the math in your head. I don't really need you to show steps, but we get 36 pi cubic inches. So if you got 36 pi cubic inches, good job. All right, on to number 9. Now we're going to find the volume of a pyramid. Now, we talked about the definition of a pyramid in previous classes. Here's a pyramid. You don't really need a specific definition. It's pretty obvious what it is if you've seen one. To find the volume of a pyramid is pretty easy. All you have to do is find the area of the base, this purple part. So that would be considered capital B. And then you multiply it by the height, which is the perpendicular distance from the base to the apex of the pyramid, also called the vertex. And then you multiply it by 1/3. Or you can also say divide by 3. Multiplying by 1/3 is the same as dividing by 3. So let's do a couple of these problems. Actually, let's just do one, number 9, then you can try number 10. So step 1, there's going to be 2 steps for each of these. We're going to find the base area, which is just 4 times 3, because the base is just a rectangle. So that equals 12. And step 2, we're going to find the actual area now, or excuse me, the volume. Volume is equal to 1/3 base times height. That's the formula that I gave up there for the volume of a pyramid. So the volume is equal to 1/3 times the base area, which we found up here. So I'm going to go and highlight that, and you see where that came from. And then times the height, and the height of the pyramid is 8. So just crunch those numbers, and we get 32 cubic feet. Now, if you're wanting me to show every step of this, we don't really have time to do that, and arithmetic is a prerequisite for this course, along with beginning algebra and pre-algebra. So I can't really show each of those steps. You should already know how to do that. But when you multiply 1/3 times a whole number, you can just write 12 over 1 and 8 over 1, and then you multiply these straight across to get 96, and you multiply these straight across to get 3, and you get 96 over 3. You can reduce that, and you get 32. Now, there are easier ways to do it. What I did is I just multiplied 1/3 times 12 in my head, and I got 4, and then multiply 4 times 8 to get 32. But that's the procedure nonetheless. So I'm not going to show that on every single step. We just don't have time. That's stuff that you should already know. But anyway, number 10 is going to be pretty much the same type of problem. So try number 10, and when you come back, we'll do it together. All right, we're back. So step 1, we're going to find the base area, which is just 5 times 5, length times width. In this case, it's a square, so they're the same length. And the volume is equal to 1/3 times the base area times height, which is that formula that we got up there. So volume is equal to 1/3 times the base area, which is 25, times the height, and the height is 6. So again, the easiest way to do this is to multiply 1/3 and 6, and you get 2, and 2 times 25 is 50. You can do it however you want to do it. There's a lot of different ways to do it, but you should know how to do it at this point. You may be a little rusty on that, but that's something that you should be able to figure out pretty quickly. You can always go back to my arithmetic course if you have trouble with that. So if you got that answer, good job. Now for number 11, we don't really have time to do number 11. We have to find the base area. Just as this formula says, we have to find the base area over here, and we have to find the height and then multiply it by 1/3. Finding the base area is kind of a long process, as you learned in the previous classes. You have to take that hexagon. I gotta draw that correctly. That hexagon. I'm not really drawing this that well, but then break it up into a bunch of triangles and do all that kind of stuff. Find that area and then multiply by the height and divide by 3, and then you've got the volume. Again, we don't have time to do that here. But I'm going to show you how to do that when the class is over. You can, when I give you screenshots of the notes, that the work will be there. But again, it's just the same process. And also, I'm going to show you a faster way to find the area of regular polygons in future classes, just so you know the fastest way to do it. I didn't show you the fast way in previous classes just because it would defeat the whole purpose of learning that material. But we're going to skip number 11 and number 12. And we're going to go straight to volume. Again, skipping number 11 and 12 just because it would take too long. So the volume of a cone is like a party hat. You may have seen like a party hat or something, or a lot of examples of cones. I can't really think of many off the top of my head, but a party hat is one example. And so let's do it. Number 13, we're going to use that formula. Notice that this formula is the same as the formula for finding the volume of a cylinder. The only difference is you're multiplying by 1/3 because it's a cone now. So the volume of this cone is equal to 1/3 pi r squared h, and r is 4 and h is 10. 4 squared is 16. 16 times 10 is 160. Let's see here. Now it's actually not necessary to even do any of this simplifying. You can just take this and then just put it into your calculator if you really want to. I'm just programmed to simplify that stuff, but 160 times pi equals, and then divided by 3 equals, and we're supposed to round off to the nearest thousandth, so 167.552 cubic inches. And let's try the next one here. Volume is equal to 1/3 pi r squared h. 1/3 pi, and r is not 6, it's 3. Be careful about that. So volume is equal to, if you do all the math on that, you get 27 pi. And we're supposed to round to the nearest thousandth. So 27 times pi equals 84.823. And I forgot to write an approximately equal to sign in the previous problem. Remember, whenever you round off, you got to write approximately equal to, and that is cubic centimeters. So over here, let's change this to approximately. All right, so why don't you try number 15. I got that formula there in the window, and when you come back, we'll do it together. All right, we're back. So the formula is volume equals 1/3 pi r squared times h, and you can just plug that into your calculator. So 7 squared is 49, so 49 times 19 equals, then times pi equals, then divided by 3 equals, and we get 974.941. So why don't you try, all right, if you got that answer correct, good job. Again, round off to the nearest thousands, try number 16, and when you come back, we'll do it together. All right, we're back. Volume is equal to 1/3 pi r squared. R is not 8, it's 4, and the height is 8. You can enter that into your calculator. 4 squared is 16, so 16 times 8 is equal to, and then times pi is equal to, and then divided by 3 equals, and we get 134.041, and that is cubic meters. So if you got that answer, good job. So again, we're just learning how to find the volume of various figures. Now, here's some more problems here. If you notice, all the shapes that we've been looking at are, many of them are right shapes, meaning this is a right cylinder, it's straight up and down. And this here is a right pyramid, and this is a right cone. That means they're just going, it goes straight up from the center. It's symmetric on either side. But for the pyramid formula and also for the cone formula, it doesn't really matter if they're right cones or right pyramids. So they can be, they don't have to be going straight up and down. They don't have to be symmetric on either side. You see these pyramids here, they're not symmetric. But the formulas still work. So for example, our pyramid formula was 1/3 times the base area times height. So the base area is obviously 6 times 6 because it's just a square. That's what those tick marks mean. And therefore the volume is equal to 1/3 times the base area times height. Again, probably just do the same way I did it before, write that formula down there. I don't need it up here. So the volume is equal to 1/3 times 36 times height, and then we get 108 cubic centimeters. So the whole point of that is to show you that the formula for the volume of a pyramid, it works even when you don't have a pyramid that is symmetric. So why don't you try number 18? It's the same type of problem, and when you come back, we'll do it together. All right, we're back. So step 1, the base area is equal to 7 times 4 because it's just a rectangle, and therefore the volume is equal to 1/3 times the base area times height. Base area is 28 and the height is 5. And so we get 140 over 3. And you can just do that in your calculator if you want to. We get 46.7 cubic inches, and that is that's rounding to the nearest 10th place. So if you got that answer, good job. So in this problem, notice we didn't really have to round off because we got the exact answer. But in this problem, we had a repeating decimal, so we had to round off to the nearest 10th place. Okay, so for number 19, we don't really have time to do number 19. Again, it's a regular polygon. You just find the base area, and you know, if we found the base area from the previous problem, I'll go ahead and write that here, and we'll come back to that. So I'll leave that for your notes. But number 20, you can do number 20. It's fairly easy. This base is a right triangle, which means we can find the area pretty easily because we have the height and the base right there. Remember, area of a triangle is 1/2 base times height. Then you just multiply by the height. Now, because this is a right angle here, that means 4 is the height of the pyramid. So see if you can do number 20, and when you come back, we'll do it together. All right, we're back. Step 1, the base area is 1/2 base times height. So 1/2 base times height. You could say that 6 is the base and 5 is the height also. It doesn't really matter. And so we get 15. So now we're ready to find the volume of the pyramid, which is 1/3 times the base area times height. The base area is 15 and the height is 4. And we get 20. So the volume is equal to exactly 20 cubic meters. All right, on to number 21. Find the volume of the following figures. Now we have cones. These are cones, but they're not symmetric cones. They're cones going off to the side. But again, this formula for a cone, it still works even if it's a cone going off to the side. Just like this pyramid formula worked for pyramids that are going off to the side. So just be aware of that. So we're going to demonstrate now that the formulas work for these cones also. So volume is equal to 1/3 pi r squared times h. 1/3 pi 7 squared times 10. And we're supposed to leave our answers in terms of pi. So that means we can't really simplify, or we can't just use the calculator. 7 squared is 49, and then 49 times 10 is 490. So we have 1/3 pi times 490. And then we'll continue up here. And then you can just put the pi and the 490 together. You know, if you want to, you can do all this stuff in your head. It's not really that necessary to show all these steps if you can do it in your head. So we get 490 pi, and then the final answer, if you want to write it in the most compact form, which you always should if you can, it would be 490 pi over 3, and the units are cubic feet. So again, the whole point we're trying to demonstrate here is that the volume of these cones that are not symmetric, to find the volume, you just use the same formula. So let's try number 22. So volume equals 1/3 pi r squared times h. So we've got 1/3 pi, r is 3, not 6, times 9. And we get 27 pi. So if you notice, these are the same answers that we got for the other cones because they have the same radii and the same height. Doesn't matter if they're going off to the side. Now be aware that this 9 is the height because this is a right angle. So it's kind of a strange cone, but it's still a cone, and that is the height. So try number 23. We're still using the formula for a cone, and when you come back, we'll do it together. All right, we're back. Volume is equal to 1/3 pi r squared h. And we have 3 squared times 7. And it looks like we're going to simplify to 21 pi cubic inches. So if you got that answer, good job. Go ahead and try number 24, and when you come back, we'll do it together. All right, we're back. Volume equals 1/3 pi r squared h, just showing the formula. You don't really have to show it every time, but it's probably good if you do. The radius is not 8, it's 4. The diameter is 8 times the height, and we get 48 pi cubic centimeters. And you can do that on your calculator if you need to. 4 squared is 16 times 9 is 144, I believe, and then divided by 3 is 48. All right, number 25. We're going on to something called Cavalieri's principle. This is kind of a weird principle. It's not that difficult to understand, I guess, but it's something that's a little weird. So if two solids have the same height, so I'm going to draw a solid, and notice how this shape has the same height as this shape down here. So it has the same height, and also if you look at the cross-sectional area, now cross-sectional area might be a little confusing if you've never heard that before, but what that means is if I take this tower here and I slice it, so I have a slice right there, just a thin two-dimensional slice, and I take that out, it's going to be something like this. I didn't draw that very well, but it's just a rectangle. You have 2 feet by 8 feet. And if I take a slice out of each of these parts, you see the cross-sectional area is the same for each of those slices. Well, the same is true for this figure down here. If I take a cross-sectional slice, that's 2 feet, and then this length here is 8 feet. So if I take that slice out, it's going to be another 2 by 8 rectangle. So that means the cross-sectional area at every level of this figure is the same as the cross-sectional area at every level of this figure. So there's two things that are similar about these two shapes. Number one, they have the same height. They both have a height of 8. And number two, they both have the same cross-sectional area because it's 8 by 2. 8 times 2 is 16 at every level. So if that is true, if those two things are true, Cavalieri's principle tells us that the volume is the same. So that's the whole point. I know that seems kind of complicated, but all that means is even though this is not a rectangular prism, you can use the formula for a rectangular prism. So 2 times 8 times 8 And again, it doesn't really matter what order you put those in. Now we get 128 cubic feet. So it's the same volume as that other problem we did. So why don't you try number 26? Again, we can't find the volume of this shape directly because we don't have any formula for that weird shape. But because the cross-sectional area is the same as the cross-sectional area for the corresponding rectangular prism, and the height is the same for a corresponding rectangular prism. In other words, let me just draw that out real quickly. So let's say you have up here something like this. I'm not drawing it perfectly, but and this is 3 inches, and this is 3.2 inches, and this is 1 inch. Then the volume of this rectangular prism is the same as the volume of this weird shape, because the height is the same, and the cross-sectional area is 3 by 1 for each slice. So you can find the volume of this rectangular prism, and that's going to be equal to the volume of this shape down here. So go ahead and try 26, and when you come back, we'll do it together. All right, we're back. So we'll just pretend that this is a rectangular prism, and we'll just plug the numbers in. And we get 1 times 3 times 3.2. Again, it doesn't matter what order you put that in there. And we get 9.6 cubic inches. Same volume we got for the shape that looks exactly like that, except it's a rectangular prism. So now the same is true for these cylinders. You see, we learned how to find the volume of a cylinder. And if you take the corresponding cylinder that has the same height, but now it's a right cylinder, again, there's 2 characteristics we need to use Cavalieri's principle. One characteristic is that the height has to be the same. So we see that the height is the same for both. These are both 20. But now if you take slices, you see that the slices are circles with radius 6. Well, if you take the slices here, if you make that radius 6, then you have the same cross-sectional area for each one of those slices. They're just circles with radii 6. So all we have to do is find the volume of the corresponding right cylinder. So volume equals pi r squared h. That's the volume of a right cylinder. And we have pi times 6 squared times 20. And it says for numbers 27 through 28, leave your answer as multiples of pi. So 36 times 20, that would be 720. Again, we got the same answer that we got for the previous problem, because the previous problem was just a right cylinder that had the same height and the same cross-sectional area at every level. So why don't you try number 28? You can use this formula for 28, even though it's not a right cylinder. And when you come back, we'll do it together. All right, we're back. So the corresponding cylinder would be a right cylinder with height 9 and radius 2. So you just find the volume of this cylinder, and that by Cavalieri's principle, it must be the same volume as that weird shape up there. So volume is equal to pi r squared h. R is 2. Actually, R is not 2. Whoops. So it's so easy to get fooled by that. R is 1. And so now we just get 9 pi cubic inches. So if you got that answer, good job. Okay, on to the next thing here. Now recall in a previous class we learned the idea of a prism. A prism is a 3-dimensional shape with 2 congruent and parallel sides called bases. That's not a very detailed definition, but it's all we need for this course. So these are examples of prisms. You see the colored green part, those are the bases, and they're congruent and they're parallel. And be aware that sometimes the prisms are set so that the bases are actually not on the ground, but those green triangles, even though they're not really, you wouldn't necessarily think of it as the base because it's not set on the base. It's still the base because they're congruent parallel prisms. So what this formula tells us is to find the volume of any prism, you just take the base area, B, and then you multiply by the height. Now, we already figured out how to find the volume of rectangular prisms, but and we used length times width times height. But if you consider the length and the width to be on the ground, those dimensions, then this would be base area, capital B. Or if you consider the height and the width, if you change its orientation so that this is the base, then width times height, that would be capital B. And length would be height. So it just depends on how you set it. So this formula works for rectangular prisms, and it also works for every other prism, so just be aware of that. So now, just to show you that it works for a rectangular prism, V equals base area times height, and then base area, in this case, the base is obviously going to be the bottom, so that's going to be length times width. So the base area is 3 times 5, and then the height is obviously 2. So the final answer is 30 cubic feet. So that's just an example that shows you that you can find the volume with a rectangle with this formula for a rectangular prism. So now number 30, it's important to understand that the bases are actually trapezoids. So remember, the area of a trapezoid, the base area is going to be the area of a trapezoid. I'm going to go ahead and write that just so you know what I'm doing. And that, if you don't recall, that is height times the sum of the bases divided by 2. And so let's go ahead and plug those numbers in. And we get the height is obviously 4. One base is 7, the other base is 8, and then just divide by 2. And you can do that in many different ways. But I'm going to, it looks like it's going to be 30. So now, step 2, we're actually going to find the volume of the entire thing. So that's base area times height. The base area is 30 we just found. Multiply that by the height. Now the height would be 10. That's this length here. Now again, it doesn't look like that's going to be the height, because we're making the base the sides. You don't normally think of a base as a side, but the bases are always the congruent prisms, the congruent and parallel prisms. So V equals 300 cubic inches. Just be aware of that. This does not look like the height because it looks more like length, but it is the height. All right. So this formula, again, it's kind of confusing because this formula is relative to how the shape is sitting. And the same thing for a rectangular prism. So for number 31, you've got right triangles as bases. So you just need to find the area of one of those right triangles. Now it's going to be easy to find the area of a right triangle because the dimensions are the base and the height. So try number 31, and when you come back, we'll do it together. All right, we're back. So the area of the base is equal to 1/2 base times height because that's the area of a triangle. So the base area is equal to 1/2 the base. We can consider to be 4, and the height we can consider to be 3. So the base area is equal to 6. Again, I'm looking at this orange triangle. This I'm considering to be the base, and this I'm considering to be the height. All right, step 2. Now we're going to find the volume. The volume is base area times height. The base area is 6, and the height is 5. It doesn't look like the height. It doesn't look like the height because it's on its side, but that is called the height. It's all relative. So millimeters, cubic millimeters. Volume is equal to 30 cubic millimeters. If you got that answer, good job. So for number 32, it might be a little more challenging because all that green part there is the base area. So you have to find the area of the rectangle, and then you have to add it to the area of the triangle. And it might look like you can't find the area of the triangle because you don't have the base, but you do. It's there somewhere. Remember, so try number 32, and when you come back, we'll do it together. All right, we're back. So step 1, the base area is equal to the area of the rectangle, and I should probably draw this out. Area of the rectangle plus the area of the triangle. Area of the rectangle is length times width, as always, and the area of the triangle is 1/2 base times height. Again, all these letters are relative to what you're talking about, so don't get confused by all this. So capital B is equal to 4 times 7 plus 1/2 times the base of the triangle. Now, it doesn't look like we have the base, but this rectangle is a parallelogram. Remember, all rectangles are parallelograms, which means opposite sides are congruent. So if this side is 7, that means this side must be 7, and that side is the base of the triangle. So the base of the triangle is 7. And the height of the triangle is 2. We're given that. So the base area is equal to 28 plus 7, which is 35 cubic meters, and I guess we don't have to write the units because it's an intermediate step. So now we're going to find the volume. Volume is just the base area times the height. So the base area we just found is 35, and the height is 12. Again, it doesn't look like the height. You know, the distance, you would think that the distance 4 plus 2, you would think that would be the height, and technically it is when it's sitting in this orientation. But the height is always perpendicular to the bases. So 12 times 35, you can get out your calculator if you need to for that one. It looks like it's going to be 420, and the units are meters, so cubic meters. So if you got that one right, good job. Okay, on to 33. Volume of a sphere. So this is going to be pretty easy. Again, it's just another formula to memorize. So volume equals 4/3 pi r cubed. And I should probably write the formula, I guess. R cubed. So volume equals 4/3 pi, plug in the radius. And we're supposed to leave our answer to the nearest tenth. So you can just get out your calculator. It's probably best to do 8 and then the x cubed button. So the x cubed button probably looks like this. It really depends on what calculator you're using. You may have to use this button. So plug in 8 and then plug in 3. Or plug in 8 and then push this button, then push 3 and then equals. And that will get you something. So I got 512, and then times pi is equal to, then times 4 is equal to, then divided by 3 is equal to. So the volume is approximately equal to 2,144.7 cubic feet. All right, number 34. We'll try one more of these before you do one on your own. So again, these are fairly easy, just plugging in numbers to the formula. So volume is approximately equal to, they get out the calculator. So 5 cubed is 125, so 125 times pi equals, times 4 equals, then divided by 3 equals 523.6 cubic centimeters. All right, so it's time for you to try a problem. Try number 35, and when you come back, again, we're just getting practice with using this volume formula. That's all we're doing. So try number 35, and when you come back, we'll do it together. All right, we're back. Volume is equal to 4/3 pi r cubed. That's the volume of a sphere. So we'll just plug in the radius. So in your calculator, 9 cubed equals 729. then times pi equals times 4 equals, then divided by 3 equals. So the volume is approximately equal to 3,053.6 cubic inches. If you got that answer, good job. Again, this stuff is not hard. You're just plugging in numbers. So try number 36, and when you come back, we'll do it together. All right, we're back. So the volume is equal to 4/3 pi r cubed, and volume is approximately equal to, and just use the calculator, 4 and then the cube button. Should get 64, and then times pi equals, and then times 4 equals, and then divided by 3 equals 268.1. So it's very common to not enter the numbers into the calculator properly. If you're having trouble with that, don't get frustrated. Just figure out how to do it, and we'll go on to the next one here. So now we're learning the volume of composite figures. We learned how to find the area of composite figures. For example, I'll give you something like this, and then I might give you like a semicircle, or I might like cut something out of it like a triangle, and we're finding the area of all these composite figures. Composite means made up of more than one thing. So now we're applying that to volume. Okay. So now we have an ice cream cone, and we're kind of assuming that this is a hemisphere. A hemisphere is half of a sphere, that ice cream part. And obviously the cone is a cone. I should have used that as one of an example of an actual cone, an ice cream cone. So the volume is equal to the volume of the cone plus the volume of the hemisphere. Again, if you take a sphere and divide it in half, it's called a hemisphere. Now to find the volume of a cone, we just get out our volume formula for a cone, and that is 1/3 pi r squared times h. And the volume of a hemisphere, we just found those as 4/3 pi r cubed. But because it's a hemisphere, we have to divide it by 2. So that might seem kind of complicated, but really it's just plugging in numbers. It's not that difficult. So 1/3 pi r squared times the height. Now for the cone, the radius, we can see the radius of this cone. The radius of the cone is this length here, from here to here. And that's the same length as the radius for the actual hemisphere. So just be aware those radii are the same length. So that's why we said the radius of the cone, the base of the cone is 4. And again, this cone is upside down, but this part is still considered the base. So now we need to find the height of the cone. Now the height of the cone is not it's not clear just by looking at these numbers. 15 is not the height of the cone. The height of the cone is from here to here. We don't have that length. So how do we find it? Well, we have this length, but that's horizontal. How are we going to use a horizontal length to find the vertical height of the cone? Well, if you rotate this radius down, again, the radius is the distance from the center of the sphere to a side, then you see that this distance from here to here is also 4. Again, a radius is the distance from the center of this pink ice cream, the strawberry ice cream, to a side. That has to be 4 because the radius, the distance from here to here is 4. That's the radius. So that means that this distance from here to here is 4. So we know the total distance is 15, and the distance from here to here is 4. So to find the height of the cone, which is what we're really looking for, this distance here, we just take 15 and subtract 4. So the height of the cone is 15 minus 4. And then we move on to the hemisphere. R is obviously 4, so 4 cubed, and then all over 2. Because it's a hemisphere, we have to divide the sphere by 2. So now all we have to do is this math. It might be easy to simplify some of this stuff before we enter it in our calculator. So 15 minus 4 is 11. And 4 cubed is 64. And then probably the easiest thing to do is just use the calculator at that point. So I'm going to get my calculator out. And we have 16 times 11 equals times pi equals, and then divided by 3 equals. So 184.306. And I'm going to carry out some more decimals. And you might think to yourself, how come you don't just do it all in the calculator all at once? Well, that's because when you try to add things, the order of operations kind of gets mixed up sometimes in the calculator, so you got to really be careful of that. So now let's get the calculator out again for this second part. A lot of different orders to do this. I'm going to do 64 times pi equals times 4 equals divided by 3 equals, and then divided by 2 equals, and we get 134.041. And I'm carrying out extra decimals just because I want to avoid, again, round-off error. So actually, before we get rid of that calculator, let's keep that number in there. We already have that number, so now let's just add 184.306769 equals, and we get 318, approximately equal to 318. I'm sorry my calculator keeps going down, but whenever I write it just automatically minimizes it. 0.3, I can't remember what we're supposed to round off to, nearest hundredth place. So rounding to the nearest hundredth place, we have, sorry, I'm just waiting for my computer to speed up here, 0.35. And the units are centimeters, so that's cubic centimeters. And there you go. So that is the volume of that ice cream cone, the cone and the hemisphere. So now I want you to try number 38. So go ahead and attempt number 38, and be aware that there's two parts. So there's the red part, it's a cube. So that's just a rectangular prism. You just use length times width times height for the red part. And for the blue part, remember its volume is equal to 1/3 times the base area times height. So finding the base area of this pyramid is going to be really easy because it's a square base pyramid. And the height, of course, is 4. So go ahead and try number 38, and when you come back, we'll do it together. All right, we're back. So step 1, I'm going to, well, let's just write it this way. So the volume is equal to volume of the cube plus the volume of the pyramid. And volume of the cube, that's obviously just 5 times 5 times 5. And volume of the pyramid is 1/3 base times height. And I'm sorry, I'm going to go ahead and write all that stuff. I just want you to know exactly what's going on here. 1/3 base area times height. And so 5 times 5 times 5. And we have 1/3 times the base area, which is just going to be 5 times 5. You know, because the base is just, again, it's as a square. And then we multiply by the height, and that's that green 4 millimeters up there. That's the height of the pyramid. So we get 125 plus 100 over 3. And you know, you can put this into your calculator, or if you want to simplify it first and write this and then put that in your calculator, you can do it. There's so many different ways to do this. So if you don't want to simplify it to 100 over 3, that's okay. But now we're going to get out the calculator, so I'm going to enter in 100 over 3 first. 100 divided by, 100 divided by 3 equals plus 125, and that's 158.33. So volume is approximately equal to 158.33 33. And what are the units? They are meters, so we have cubic meters. So if you got that answer, good job. If you didn't get that answer, that's okay. Just go back and figure out what you did wrong. Okay, on to the next problem. We've got two rectangular prisms. So the total volume is equal to the volume of one rectangular prism. I'm going to call it prism 1 plus the volume of prism 2. So prism 1, I'm going to make this top prism, and prism 2 is going to be the bottom prism. So total volume is equal to the top prism. We have the width and the height, and we do have the length. This length here is 6, so that means that this length must be 6 also. So that would be 6, that's the volume of one prism, and then the volume of the other prism would be the width times the length times the height. Again, all those terms are relative based on how you think about the orientation of the prism. So then we get 54 plus 120, and you can use a calculator for that if you need to. That would be 174 cubic millimeters. So on to number 40. I want you to go ahead and try number 40, and when you come back, we'll do it together. All right, we're back. The total volume is equal to the volume of the first prism, which I'm going to say is this top prism, plus the volume of the second prism, which I'm going to say is the bottom prism. So the volume is equal to the height of the top is 1, the width is 12, the length is 5. If you can see that length down there, that length transfers because those are rectangles, which are parallelograms, and opposite sides of parallelograms are congruent, so that 5 transfers up. And then we have 3 times 16 times 5 for the bottom prism. So volume is equal to 60 plus 240, it looks like. And then we have 300 cubic inches. So if you got that answer, good job. Okay, so on to number 41. Just more composite figures here, not really a big deal. We're learning to find the volume of composite figures. So the total volume is equal to the volume of the rectangular prism. I'm just going to call it a prism, plus the volume of the half cylinder. There may be a special name for a half cylinder. I don't really care. It's not that big of a deal. So length of the prism is length times width times height, and the volume, or the volume of a prism is length times width times height, and the volume of the half cylinder is the volume of a cylinder, which we learned is pi r squared h, and then we have to divide it by 2 because it's only half the cylinder. Now I want you to understand that when you have these little dots here, that just assumes that that's the center. You're going to get many problems where they have dots there, and if there's a dot, then you're supposed to assume that that's the center. Okay, so we just plug numbers in. We have 6 times 7 times 25, and again, I don't really care which is which in terms of length, width, and height. Again, it doesn't matter. We have pi times r squared. Now, what is r? This length here is 6. We just transfer that length up, and so the radius is just half of 6, so that would be 3. So 3 squared times the height, which is 25, because it's on its side, and then divided by 2. So the volume is approximately equal to, we can get out our calculator for this because these are pretty big numbers. 7 times 6 is 42, so 42 times 25 is 1,050. And then 3 squared is 9, and then 9 times 25 equals, and then times pi equals, and then divided by 2 equals. So that would be 353.429, and I'm going to carry out a bunch of decimals just so we don't have round off error. And I'm going to just keep that number in my calculator and push plus 1050 equals. So the volume is approximately equal to 1,403 point, what are we supposed to round off to? The nearest hundredth place if necessary. So that would be 0.4 cubic meters. Again, just another example of a composite figure. So for number 42, I'm going to give you a hint. First of all, we have two prisms. We have the top prism and the bottom prism. The bases, the bottom prism is obviously a rectangular prism. So that's going to be easy, length times width. But the top prism, the bases of that prism are trapezoids. So you're going to have to use the trapezoid formula. If you forgot the trapezoid formula, the area of a trapezoid is height times the sum of the bases divided by 2. So go ahead and try number 42. When you come back, we'll do it together. Also, I should remind you, the volume of a prism is base area times height. So this is going to be the base area of that trapezoidal figure. So try number 42, and when you come back, we'll do it together. All right, we're back. So the total volume is equal to volume of prism 1, which I'm going to call the top prism, plus the volume of prism 2, which I'm going to call the bottom prism. So the top prism, that's just going to be the height, which is 1 times the sum of the bases. And we're told that this length is 1. So that means that this length is also 1. We're just supposed to assume that. So 1 is one of the bases, and then this is the other base. So these are the two bases that I just circled there of the trapezoid. So the second base we don't know either, but we do know that this length is 4, so it just transfers up here. So that length is 4. So again, just to be clear, the bases are 1 foot and 4 feet. So plug in 4 and then divide by 2. So that's the area of the base of that trapezoidal figure. So then we have to multiply that by the height. And then the height of that top trapezoidal figure is 5. Then we do 2 times 4 times 5 for length times width times height of the bottom prism. And now we're ready to go. So obviously this would be 40. That's pretty easy. And then 1 plus 4 is 5. And 5 times 1 is 5. 5 times 5 is 25. Divided by 2 is 12.5. I may have done that pretty quickly, but again, you can do it however you want. And then we get 52.5 cubic feet. So that was kind of a challenge problem, but if you got it right, good job. If you didn't, just go back and figure out what you did wrong. That's okay. So on to similar solids. So we need to talk about the concept of similar solids. We learned about similarity in reference to two-dimensional shapes. For example, if two shapes look like they have the same general shape, but they're different sizes, then those are similar shapes, and that's what it refers to in 2 dimensions. But now we're talking about 3-dimensional shapes. It's pretty much the same idea. 3-dimensional figures that have the same shape but are different sizes are similar solids. But a more technical definition is solids with equal ratios of corresponding dimensions. So I know that sounds pretty complicated, but all that means is obviously the way that these rectangular prisms are sitting, these two are corresponding sides, and these two are corresponding sides, and so on and so forth. So we want to find the ratio of corresponding sides. So we'll take the smaller one, actually we'll take the bigger one divided by the smaller one. And we want to see if that's equal to the other ratios. So we'll take the bigger one divided by the smaller one, and again, these have to be corresponding sides as usual. And we want to see if this is true. So 3/2, the big question is, does 9/6 reduce to 3/2? And it does. Does 6/4 reduce to 3/2? Yes, it does. So those ratios are all equal. So we can say, yes, they are similar solids. So now 44, just doing the same thing. So the radiuses, we'll take the smaller side and divide by the bigger, or the smaller radius and divide by the bigger radius. We want to see if that's equal to the smaller height divided by the bigger height, and we get 1/2 is equal to 1/2. So the answer is yes, they are similar solids. Okay, number 45. We'll do one more of these before you try one on your own. So we're going to take the smaller diameter and divide by the bigger diameter. And we're going to see if that's equal to the smaller length divided by the bigger length. So if we reduce those, we get 5/8. And over here we get 2/3. So obviously that's not correct. And we can say, no, they're not similar solids. So this is pretty easy. All right, why don't you try number 46, and when you come back, we'll do it together. All right, we're back. So the heights, I'm going to take this bigger height, divide by the smaller height, and see if that's equal to the ratio of the sides of those squares, and they're both the same because they're squares. So now we reduce 8/6, and we get 4/3, and we can see that the ratio of corresponding sides they're equal. So those are similar figures. So if you got that answer, good job. Try number 47, and when you come back, we'll do it together. All right, we're back. 4/2, we'll see if that's equal to 10/4, and we'll see if that's equal to 4/2. And 4/2 is just 2, obviously. 10/4, you can get a calculator if you want, but that's 2.5, and then we get 2. So obviously this is not correct, and so they are not similar solids. So if you got that answer, good job. Again, similarity is pretty easy to deal with. So now we're going on to proportional volumes. Now, we learned in a previous class that if two shapes are similar, then if you take the areas, let's say this is area, the area of that triangle is area 2, the area of this triangle is area 1. If you divide the areas, then that quotient is equal to the ratio of corresponding sides. So let's say that this side is A and this side is B. You take A over B and you square it, and that's equal to the ratio of the areas. We called that the proportional areas theorem. That was quite a while ago in a different class. But now we're talking about the proportional volumes theorem, and that pretty much works the same way. What that says is that if you take the volume of one solid and divide by the volume of the other solids, if these solids are similar, then the ratio of the volumes is equal to the ratio of the corresponding sides cubed. So it's the exact same theorem as the proportional areas theorem. Instead of squaring, we're just cubing. So with area, it's squaring the ratio of corresponding sides, but with volume, it's cubing the ratio of corresponding sides. So let's try some practice problems. If you didn't understand that, that's okay. You'll get it as we do more practice problems. So it says here the ratio of corresponding sides, i.e. the scale factor. The ratio of corresponding sides is also called the scale factor, so be aware of that. We went over that in a previous class. So the ratio of corresponding sides of the two similar solids is written below. That's the scale factor here, that's written. Given the volume of the smaller solid, find the volume of the larger solid. So we take the ratio of the volumes. So we take the smaller solid, the smaller volume, and divide it by the larger volume, which I'm going to notate as VL, volume of the larger. That's equal to the scale factor cubed. Now, you can write the scale factor in different ways, but I had to write it with the smaller number on top. The 2 is on top because we wrote the smaller volume on the top. Now, how did I know that that was a smaller volume? Because they told us. The volume that we're given is the volume of the smaller solid. So now we just do basic algebra to find the volume of the larger solid. So it says find the volume of the larger solid. So first thing we have to do is cube this. Now you may be thinking, well, how in the world do I do that? Well, that's just 2/3 times 2/3 times 2/3. That's what it means to cube something. And multiplying a bunch of fractions like that, that's really easy. It's not hard at all. You're just multiplying straight across. So 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. You don't have to show all this, but I'm just doing that for your sake. So now, there's a lot of different ways to do this, but probably the easiest way to do it, I've been showing in this class, is just to cross multiply when you get this situation. I realized that I was not showing you the way I learned in my beginning algebra course. I was showing you the quick way, multiplying both sides by the lowest common denominator. So I'm just going to do it a quicker way because I just don't have the patience to show you that way we learned in beginning algebra. That just takes too long. So we're going to do it quicker. We're just going to use cross multiplication. So 8 times VL, that would be 8 VL. And then 27 times 40, you can get the calculator out for that. 40 times 27 equals 1080. Then divide both sides by 8, and we get 135. So the volume of the larger solid is 135 cubic inches. All right, so let's do one more of these before you try one on your own. So the scale factor is 4. And again, we're told that this is the smaller volume, so I'm going to put the smaller one on the top. You could reverse it if you wanted to, it doesn't really matter. And the larger one is in the bottom, so these are the ratio of the volumes. One volume we know, the other volume we don't know. And that has to be equal to the ratio, the scale factor cubed. So because we're putting the smaller volume on top, I have to put 1/4 cubed. Because 4 is the same thing as 4/1. And that means that the ratio is 1:4 or 4:1. But because I'm putting the smaller volume on top, I have to flip it because 1 represents the smaller number. So that can be very confusing. If you don't understand that, you're not going to be able to do these problems. So be very careful about that. So that would just be 1/4 times 1/4 times 1/4, which is 1/64, and I should probably write that. So now we get 1/64 is equal to 2 over the volume of the larger solid. And now we can just use cross multiplication. So 2 times 64 is 128. VL times 1 is VL. And there you go. So now we just put our units, and we have cubic meters. Now, I want to make you aware of something. If you put the smaller volume over the larger volume, and then you write 4/1 cubed, that is not correct. Because the smaller volume is on top, but the bigger dimension is on top on the right side. You can't have smaller on top and then bigger on top. On the other hand, if you write VL/2, which you're perfectly capable of doing that also, then you would have to flip the other side, and this would be correct, as long as you've got bigger on top on both of the fractions and smaller on the bottom of both of the fractions. But if you were to mix this around and put 1/4 cubed, that would not be correct, because the smaller dimension is on top and the larger volume is on top. So I know that seems kind of confusing, but it's really not. You have two fractions. If the smaller number is on top here, the smaller number has to be on the top there. That's the smaller volume has to be on top. So it's really not that difficult. So try number 50, and when you come back, we'll do it together. All right, we're back. So I'm going to put the smaller volume on the top. I don't have to, but I'm going to do it that way. And so that means the smaller number on the scale factor has to be on the top. So 1 is smaller than 2. So now, again, you could write it as VL/8, and then you could flip this fraction and do it like this. You get the same answer. But if you write 1/2 here and VL/8 here, you're not going to get the same answer. Or if you write 8/VL is equal to 2/1 cubed, that's not the right answer either. So just be aware of that. Okay, so now we're going to cube 1/2, which just means multiply it by itself 3 times. again, you don't have to show that work. I'm just doing that for you. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And cross multiplication, 8 times 8 is 64. And 1 times VL is VL. And the units are cubic centimeters. So if you got that answer, good job. All right, number 51, go ahead and try number 51. And I have to warn you that your answer is going to be a fraction for number 51. So don't be upset if your answer is going to be a fraction. You can just leave it as a fraction. So try number 51, and when you come back, we'll do it together. All right, we're back. So I'm putting the smaller volume on top because we're told that's the smaller volume. Larger volume on the bottom. So I have to put the smaller number on top and the bigger number on the bottom on the right side. Now again, if you write VL over 1, then you would just flip the other fraction also. It's not a big deal. You can do it either way. You'll get the same answer. But don't do it in the ways that I told you would not work. You can't write 1 over VL and then 5 over 4. That doesn't work. So now 4/5, 4 cubed would be 64, and 5 cubed is 125. We don't really have a lot of room to write that out, so just do cross multiplication. We get 64 VL is equal to 125. Divide both sides by 64, and we get 125 over 64. And we can just, I know it's kind of strange, but we can just leave it like that. There's no reason why we can't leave it like that. You know, you might want to enter it into your calculator and write it as a decimal, but I'm just going to leave it in that form. So if you entered it into your calculator, that's okay, but it doesn't say to round anything off, so we should probably put the exact answer. So I'm sorry if that kind of confused you there. All right, number 52. Now we have the same exact problems, but now the volume that they're giving us is actually the bigger volume, the larger volume. So just be aware of that. So I'm going to put the larger volume on the top, and the smaller volume, which we don't know, is going to be in the bottom. Again, it doesn't matter which, you can flip it if you want. So now the scale factor is 3, so that means it's 3 over 1 if you think of it as a ratio. Okay, so the smaller number has to be in the bottom because we have the smaller volume in the bottom. So that means 3 over 1 is correct, writing it in that orientation. If I flip the fraction on the left, then I'd have to flip the fraction on the right also. So you don't actually have to write 3 over 1. You can just write 3 cubed. Doesn't really matter. I'm going to go ahead and just write what that is. 3 times 3 times 3 is 27. I guess I'm going to keep the 1, cross multiply. We get 4 is equal to 27 times VS. Divide both sides by 27. And there's our answer. So 4/27 of a cubic millimeter. So that's a very small space there. Let's try one more of these. Again, the only difference with these problems is that you now have the volume of the larger solid. That's given to you. So 4 cubic millimeters was the volume of the larger solid. I just want you to be aware how to how to do different variations of these problems. So now, again, putting the volume of the larger solid on top. Well, actually, in this case, I'm going to put the volume of the smaller solid on top, just so you can see that you can do it in different ways. Not all ways are correct, though. And then I would have to write that a scale factor in the way it is. But again, you could write 10 over volume of the smaller solid equals 5 over 1 cubed. That would also work. As long as the tops are both the larger or both the smaller, and the bottoms are both the larger or the smaller, then it's going to work. So 1/5 cubed. 1 times 1 times 1 is 1. 5 times 5 times 5 is 125. And then we just cross multiply. 125 times VS is equal to 10. Divide both sides by 125. We have 10 over 125 cubic inches. So that's a very small fraction of a cubic inch. Okay, now it's time for you to try. Go ahead and do number 54. Remember, this volume is now the volume of the larger solid. So we're looking for the volume of the smaller solid. We're given the volume of the larger solid. So try number 54. When you come back, we'll do it together. All right, we're back. So I'm going to write the larger solid volume over this smaller solid. You may do it another way, that's okay. But that means that I have to flip this because 5 is larger. So the larger goes on the top just by the way I set it up. So 5 cubed is just 125. 1 cubed is 1. Cross multiply, we get 8 is equal to 125 VS, and divide both sides by 125. We get 8 over 125 cubic centimeters is equal to the smaller volume. So if you got that answer, good job. Go ahead and try number 55, and when you come back, we'll do it together. All right, we're back. So I'm going to put the volume of the, just to mix it up a little bit, I'm now going to put the volume of the smaller solid on top and the volume of the bigger solid on the bottom. So the scale factor is 2 over 1. 2 is the same thing as 2 over 1. So that means that if you write it this way, the bigger dimension is on top. But that's not how I did it, so I have to flip it because we wrote the bigger volume on the bottom. So now we have 1/8. Cross multiply, we get 8 VS is equal to 2. Divide both sides by 8. VS is equal to 2 over 8, which reduces to 1/4 of a cubic meter is the volume of the smaller solid. So we just ended up with a lot of fractions there. I didn't mean to do that, but that's just random numbers there. So if you got 1/4 of a cubic meter, good job. So now we're going to do 4 more problems here, just more problems with the idea of similar solids and the Proportional Volumes Theorem, which you can take a screenshot of if you want to. And we have 2 rectangular prisms, and we're told that they're similar, and we have to find the unknown. So we're going to use that Proportional Volumes Theorem. We know the ratio of the 2 volumes is equal to the ratio of the sides, the corresponding sides, cubed. Now we know both volumes this time, so now 80, the volume of the smaller one, or actually the volume of the bigger one over the volume of the smaller one, that has to be equal to the ratio of the sides, which are 8 over x, we don't know x, cubed. So the only difference with these problems is we're now looking for one of the sides using this principle. Now, we haven't done this stuff before. This is something pretty different. We have to find x, and it's cubed. It's inside a cube. So what we have to do first is we have to get rid of that third power because we want to get to the x. We want to isolate x, get it by itself, but we can't because it's trapped inside there. So we're going to do the opposite of cubing, the opposite of raising to the third power. The opposite of raising to the third power is called cube rooting. We've never done this before in any of my classes. So if this seems new, it is new. We're learning it for the first time here. So we're going to cube root both sides. And I made that a little too long there. Can't go over the equal sign. And that counteracts the cubing. These just cancel each other out. When I continue up here, we have the cube root. So the cube root of 80 over 33.75 is equal to 8 over x. Again, we just got rid of that that cube on the 8 over x. So now you can get the calculator out, and I think that number is not going to be too painful to deal with. Now it's very important that you do this correctly in your calculator. We haven't done this before, so you have to do 80 divided by 33.75. So do that first. 80 divided by 33.75 equals. And then at that point, keep that number in your calculator, and you're then going to push this button, something that looks like that. It has a Y and an X. So I'm going to push that button, and then you're going to push the nth root, whatever number is there, which is 3, and then equals, and we see we have a repeating decimal, so 1.33333. So you can just write that. And then we're going to cross multiply. You can consider this to be over 1. Cross multiply, we have 1.3 bar times x is equal to 8. And we're out of room, so we're just going to go up here. Then divide both sides by 1.3 bar. So x is equal to 8 over 1.3 bar. Now, I can't think of an easy way to really put this into your calculator, but just do 8 divided by 1 point, and then just put a bunch of 3's. Like a lot of 3's, and then equals, and it should give you 6. It'll give you an approximation, but it's basically 6. I should have chose those numbers a little more wisely, because I didn't want to give you weird numbers. I don't say to round off, but that would be 6 feet. That's what we're looking for. So hopefully I won't put any of those in the homework. So let's see here, 57. Let's do one more of these before you try one on your own. So the volume of the first one, which I left as a multiple of pi just to make things easier, divided by the volume of the other one, the other shape, is equal to the ratio of the sides cubed. I can actually get rid of the pi's. The pi's are just going to cancel out. So we have 1280 over 20,000. And so we're going to cube root everything to get rid of that cube. So cube root both sides, and that gets rid of the cube on the right side, so we have y over 50. And then you can just kind of enter that into your calculator. So 1280 divided by 20,000 equals, and then push the root button. Again, the root button looks like this, at least in an iPhone. And then put 3, because it's cube rooting, and then equals, and then we get 0.4. So 0.4. And we can write it over 1 if you want to cross multiply. So now cross multiply. And 0.1 times 50 is equal to 1 times y, which is just y. And then 0.4 times 50 is equal to 20. So we have 20 meters is y. And be aware that we're only finding a one-dimensional length. So it's just meters, not cubic meters. All right, so I'm going to leave those in the window. Hopefully you can see number 58. Do number 58, and when you come back, we'll do it together. All right, we're back. The smaller volume over the larger volume is equal to the cube of the ratio of the corresponding sides. And we're going to cube root both sides to get rid of that cube. And so we have b over 12 is equal to the cube root of 64 over 1728, and that should be a relatively easy number. And that is 4 over 12. You can do that separately in your calculator if you want to. The nth root of any fraction is just the nth root of the numerator over the nth root of the denominator, and it's pretty easy to explain why that is. That's not a rule that we've learned yet, but you can just take the third root of 64, and that equals 4, and take the third root of 1,728, and that is 12. Or you can just do 64 divided by 1,728 in your calculator, and then take the cube root of that. There's a lot of different ways to do it. The difference is you're going to end up with a decimal if you do it that way. Okay, so now at this point we can see that b is obviously 4. Because the fractions are equal, we know that, but we also know the denominators are the same. So the only way for fractions with the equal denominators to be equal is for the numerators to also be equal. So b has to be 4, and the units are centimeters. So if you got that answer, good job. So if you got a decimal here, then you would just take the cube root of the decimal, and then after that, you just multiply that by 12, and you should get 4. So why don't you try number 59, and when you come back, we'll do it together. All right, we're back. So I'm going to take the bigger volume and divide by the smaller volume, and that should equal 3 over x cubed. And then, of course, we're going to cube root both sides to get rid of that. And we can divide the pi's out, and we can also simplify this fraction. Divide 81 by 3, you get 27. Divide 24 by 3, and you get 8. Again, you don't have to do it that way, but that's probably the easiest way to do it in terms of entering it into your calculator. So we cube root, and that gets rid of the third power. Now this, again, you can enter 27 into your calculator, divide by 8, get a decimal, and then take the cube root of that. Or you can just realize that the cube root of 27 is 3, and the cube root of 8 is 2. And then we see that x is equal to 2. Again, it's just another way to do it, so that is inches. So if you got 2 inches, good job. Now if you got a decimal here, you should have gotten 1.5, and in that case you would have 1.5 is equal to 3 over x, and you can consider this to be over 1, and then just cross multiply. You get 1.5x is equal to 1 times 3, which is 3. Divide both sides by 1.5, and you get 2. So that's just another way to do it. So now let's take screenshots of all the work that we did today to help you with your homework and also to study for tests. Screenshot number 1, screenshot number 2, screenshot number 3, and number 4, and number 5, number 6, number 7, number 8, number 9, number 10, number 11, and number 12. Don't leave before you get your homework. Let's take a look at the homework. So here's screenshot number 1 and screenshot number 2 and screenshot number 3 and screenshot number 4. Remember, do that homework completely correctly, neatly, and put it in order in your binder. And also remember to show work. If you don't show work, if you just write the answer, then that doesn't mean anything. That just means that you cheated. You wrote the answer without actually doing the work. You have to show your work. So get that homework done, and I'll look forward to seeing you in the next class.